Hey there, team. Just wanted to take you through a quick run through of some AI coding that I've been doing. When I talk about running AI projects and that potentially your AI outputs can be quick and fairly cost effective, especially if you're running an SMB and you're not deciding to go down the big time route of AI. There's some good wins you can get off the park just using standard basic AI coding tools. Doesn't take long to put together. As you'll see, there isn't a lot of code here. The biggest thing with running AI is that you're testing and measuring the results. So you test, measure the results, see what happens. If you don't get what you want, you test and measure again, you adjust, and until you get the kind of results you're after. So this first one, quickly, is a convolutional neural network that's used for identifying text out of images. This particular example is for this, so it's looking for numbers from an image. So you could use that for scanning number plates, for example. Very quick, easy kind of image to put together. All right, so as you can see, the code is only 134 lines long. And it runs through multiple tests. We call those epochs. You'll see down here in the bottom left-hand corner of the screen that the epochs we run through are 10. I won't hit run on this because it does take a little bit of time to run through. They do 1,500 tests at each epoch, so there's a lot of work involved in terms of what the machine's doing, so it takes a few minutes to run. We won't do that here. But as you can see down the bottom here, we got a comparison of actual versus predicted. Actual being 7, predicted 7, actual 2, predicted 2. So that's where the source data tells the AI, okay, you were having a look at this image, you thought it was going to be a 2, and yes, you were accurate, it was a 2. And as you can see, if I move the screen across here, and we can see in there that the actual 7 predicted 7, and you can clearly see that there's a 7 in the number there. And it can even get fairly obscure numbers. Like you see that 5 is looking pretty obscure. That picked it up as being a 5 and predicted it accurately. And that's pretty standard, easy to do AI code. I vibe coded this, but I'm not a serious developer. I'm a vibe coder, so I pull this together using ChatGPT and XAI and Claude and various other tools, and get a good understanding of what it is that I'm doing and pull it together to get the results I'm after. The next one was a stone manufacturing data analyst. I didn't use accurate data on this test bed, so the test bed results don't reflect the actual results at the end of the day, because when we're testing to see how many days it takes to do something and how much it'll cost, you need consistent data in your data sheet. So you need actual real world data to put in there. That's kind of quite important with AI. If you don't have a baseline of really good data, you're kind of wasting your time doing any AI from that perspective. But if you've got a good baseline of data that you can feed in and train the system on what your data is and what that output looks like, then you can come up with some really quick, easy results. And again, this one took me a few days of fluffing around to get it sorted. Again, the main kind of impacts or on time frame or key challenges were around taking the various ways that you can do and code AI and figuring out which way works best. So this uses an atom model, and obviously TensorFlow in Python. And we come down here, and again, this is only about 205 lines of code. Not that much actual coding effort involved in there. And if I go down here, we can see that I ran some test data here. We ran it through multiple epochs, like a whole heap, 50 of them, and they ran through the background data and did a whole heap of training on it, and we got the accuracy right pretty good actually. And when it comes down to the actuals versus predicted, we can see down the bottom there, you might find it a little bit hard to see on your screen, but the actual days was 66.9 actually, and the predicted days was 67.54 based on the data that was in there, the training data that was in there. The cost was 55,850. The predicted cost was 55,983. So that cost came in real close to the actual. The predicted cost came in like within dollars of the actual cost. But in some cases where the cost was an outlier, and that's where having good training data, good consistent training data is super important. We got the days pretty close, within 10%, 101 days. And again, predicted days, 111. But the actual cost was 103,000 and the predicted cost was 58,000, 57,300 and what have you. So it's not very accurate on that one in terms of cost versus actual. And that's what happens when you have a small training set and the accuracy of the data that's fed into the back end isn't 100%. You can get away with some minor variations and what have you, but you want your training data to be pretty accurate. So that's why you get little outliers like that where your things where your cost models aren't consistent across the spreadsheet to what's actually in the data. So obviously the more data we have, the better results we'll get. And that's essentially it. A couple of really small AI models, and this one in particular, if I didn't say it before, you can use it to predict manufacturing costs when you're doing manufacturing, in this case of stone. You can take all your stone inputs, your material, your cost of materials, how much time it takes to do things, any other variables, all of which you can take into account, and you should take into account when you're doing your predictions. And then you just feed that data and you train the model. It outputs a model file, so there's no need to do a retrain every time you run this, even though I am, because I'm running off a test bed. And you can take that trained model, you can feed it into your newly developed system, and you can be operating it in a very short time frame for a very low cost, and it can save you a lot of time. Like if you think about it, sometimes it'll take you 2, 3, 4 hours to pull together estimates for someone who's rung up on the phone, and then what you end up with out of this is you put in the same data, it takes you 10 minutes. So when you think about how many estimates you're doing and how much that's costing you internally in terms of productivity from your sales team, when people are just fishing for a bit of information, if you can get an estimate within 10% just by punching the data in rather than going into the background and doing a whole heap of work, then that's money for jam. All right, cool. So that's a little bit of a show and tell in terms of what you can do from an AI perspective. Cool. All right. Thanks, team.